roughly an outline of what this will contain is giving you an idea what archaeo-astronomy is. Because sort of talking with a few people, it's always the initial thing, what did you say? I didn't understand what archaeo-astronomy, it's archaeo-astronomy, and I'm going to present that first so you have an idea what for discipline that actually is and what I think, that's my definition, what it tries to convey. Then, because we show or want to show how this sort of links into schools, a bit about the possibilities and opportunities this area offers to schools in the context of sort of modern, innovative ways of delivering knowledge and skills. And then, because I emphasized this citizenship, which I think also contains things like critical thinking and evaluation, how does that slot in? How do we manage to convey the key issues of citizenship with our work with kids? So first, archaeo, or what that actually is archaeo-astronomy. It's a general link between astronomy and archaeology, mainly, as you would see from the name, but it also has far more other areas that are contained in archaeoastronomy. Anthropology is in there, ethnohistory as well, because, for example, if you then look at what the ideas or the main goal is, how I would express it for archaeoastronomy, how ancient mankind perceived, visualized, and understood the heavens above, means also we need to see how myths and star stories have developed and try to understand that. That's where it sort of moves out of the realm of archaeology and astronomy more to something more like ethnohistory or other areas. So archaeoastronomy is highly interdisciplinary link and offers so many different connections, and you'll see soon so many different connections also to schools. So archaeoastronomy looks at, as I said, how ancient mankind, now when I say ancient, really take this as 5,000 to say 1,000 BC at least, how they try to understand the heavens above. Easy if we go to medieval times, you just look up in some codices and try to understand drawings or what's been written. Roman times, as same, you would go through texts. Now in that time, very difficult, no, impossible. I would say there is no written record. So the only thing, only in quotation marks, the only thing that we have are these ancient monuments. And if you think of archaeoastronomy or ancient monuments, many people think immediately of Stonehenge. And it's not only Stonehenge that's out there. If you look just at this, I'm only concentrating on Europe. I just don't have the time to concentrate on all other options and sites across the world. You've got many other sites. Here we've got Stonehenge. And this is sort of a bit referring to the first figure in the paper, which gives you a detailed list of that. You've got Stonehenge here. You've got Cavendish, another site of megalith set up here in the north of Scotland. Then you've got around in Poland, Odry, another stone circle set here. Then in Germany, this is not how the site looks like now. What's been discovered there is only a set of post holes. So actually that's a reconstruction, but that's in former East Germany here. And then if you go to the Iberian Peninsula, you can also find what's called seven stone antes. They are sort of set up burial sites all across this area. So there are far more, as you could see in these maps, spreading across even to the southern parts of Italy, Sicily, going towards Crete and further. And this is all in this European area, so a widespread, far beyond Stonehenge as such. Now, what do these monuments allow us to explore? How can we use them to understand how ancient mankind perceived the heavens above? Well, for one, these monuments show, as we say, alignment, or some show alignment. Alignment, well, this is Stonehenge sort of from a bird's eye view, and you can see ditches set up. So a very intricate construction of this site. So how they constructed it helps us to understand the potential and the complexity in these society. But you can also see this path that leads off into the distance. And this path isn't sort of orientated in some random direction. If you look along this path, depending in which direction, you see the sun rising or setting at the date of the solstice, where it's either further south or furthest north when it's rising or setting point. Spot on, more or less. So this is a very intricate and important alignment that in a monument that is well beyond a few millennia old. So these are some of the alignments, and these alignments aren't just set up through one stone and another, but this is severe landscape modeling that has taken place, creating these long pathways. So you have an intricate linkage between the site and the landscape surrounding. And actually I would have to zoom out so you could see the entire sacred landscape of that time, which spreads over square kilometers, where that also involves the River Severn, not the River Severn, the Avon, which again emphasizes then the connection, as we think, between water and the landscape and the importance of waterways in that time as well. And that then brings another point after you sort of explore these sites and see the amount of effort that must have gone into creating them. Why did we create these sites at that time? So a lot of aspects you can explore by just looking at a site that's been left by these civilizations. Now, what does that also allow you then to further look at? Well, you can also use these sites to, for example, look at the cultural heritage of this site. You can look at, well, religious beliefs then, very difficult to decipher what that means, but you can see sort of a modern interpretation of paganism, as this is actually a picture I've taken beginning of this year with one of my students going out on a field trip there, and it's just placed this figure on one of the stones, and it's been there, so it's not recreated by us. You can also then explore the nocturnal landscape surrounding this site. In this case, you can see I've used the planetarium software, but we've imported the landscape. You can see one of the standing stones, and above here you can see sort of the fading, and what I've done is I've faded out light pollution. So at the end you can see all the stars that would be visible without light pollution. So suddenly you explore pollution on this site as well. What would be there, what is there now. And you can sort of use these sites also to relearn astronomical facts. Like, if I would ask you now, where does the sun rise? In which cardinal direction, if you could pick a direction? If I ask you now, where does the sun rise? In which direction?
It rises in the east.
Rises in the east. Perfect. That's what I want to hear, and sadly that is true twice a year. Anywhere you go, that's only true twice a year. And actually, where you go here, Stonehenge, if east may be there, that's where it's set for the equinoxes. If you go to the summer and winter solstices, these are the extremes on the horizon. So we're talking about 80 to virtually 90 degrees. And if you're really picky and pedantic astronomy, you could say you can go to the North Pole and it might never set, or it might always be setting, because it's skimming the horizon. So actually, that's not true. But you see these ancient sites, mankind knew about this. So this is not a fact that sort of brought through modern astronomy and we have to learn it. We've sort of forgotten it. Why? Because we sort of encased us in these big cities with light pollution and with an obstruction of the land, with the obstruction of the horizon. So you can relearn ancient basic astronomical facts, and this is what we call an horizon observatory, and this has been built on a former spoil heap of a mining area in the midst of a built-up area in Germany. And you can see here sort of markers where if you're standing in the center you can see certain rising points, you can see big arcs. To give you an idea of the scale, this is roughly 90 meters to 100 meters across in diameter, so 45 meters height of this. And actually, this is my presentation. We'll do this. We should try to animate this. Possibly if I go to the next, he's struggling with animation. Else you would have seen a nice fly through. So these are sort of the potentials of what Archaeo-Astronomy can explore. Now, how does that link with schools? And actually, what we see is a clear and powerful linkage for school opportunity there, that we can use these ancient monuments and sites as outdoor learning classrooms. So schools can take a class out into the real world, into a site that's not normally used in a context of, say, astronomy or physics, and try to explore this site. Now, what can you explore if you visit this site? And this site is, for example, Gardens Edge, which is a nice historic landscape not somewhere isolated, some remote Scottish island. It's in the middle of the UK. You've got London here, you've got Birmingham here, Liverpool, I dare say Manchester because I've got my background in Liverpool as well, but you've got Nottingham here, Sheffield. In the midst of this, you've got then suddenly a whole national park where you've got these sites very close by, and that's where Garden Edge is a fantastic landscape where you can explore many things, of which are geology. You can integrate that into stratigraphy if you're going into archaeology, the placing of different layers. You can go into biology. You can look at ecology at that site. You can connect that with archaeobotany to explore how the landscape has changed through our interaction with the landscape. Many people think this is fantastic, we should protect this landscape. It's so natural. Unfortunately, it is completely man-made, this landscape. We have formed this boggy landscape by deforestating all that area in ancient times. Then chemistry, you can analyze pollution and erosion, and this is sort of a 3D model of a standing stone we've done with one of our work experience students, and you can actually see the runnels and funnels being eaten away by water, and this erosion has happened in the last few hundred years only, not in the other millennia beforehand. And as an astronomer there, also astronomy. You can sort of base that very tightly into the settings of light, seasons, and shadows. And in this case, it's this standing stone that I found so amazing. It is, you can see, sort of very leaning, but it's not leaning because it's sort of a very thin stone that's lent across, but it's certainly got this triangular shape. And it's not orientated in some manner. It's more or less spot-on orientated south, and this slope that you can see sort of cropping up is tilted to a certain manner that I propose you to actually use that as a seasonal sundial. So at that site you can teach, you can take your students there as a group and say, what do we know about the sun? Where does it set? Where does it rise? How does the sun move during a day? How does it move during a season? You can use that while you're there